Number needed to treat NNT. Statistical significance, p-values, does not equal clinical relevance. A highly significant p-value, less than 0.0001, can emerge from clinically trivial differences when sample sizes are large. NNT bridges this gap by translating statistical results into practical, clinically intuitive numbers. NNT answers the critical clinical question: how many patients must I treat with treatment A instead of treatment B to expect one additional favorable outcome? NTT helps clinicians decide whether a statistically significant difference actually matters in daily practice. Compare treatments across different studies. Communicate risk/benefit trade-offs to patients. Make evidence-based prescribing decisions. How to calculate and interpret NNT. The formula: NNT equals 1/rate minus rate 2. Rate equals response rate for treatment A. Rate 2 equals response rate for treatment B. Both rates must refer to the same binary outcome: responder/non-responder, remitted/not remitted, relapsed/not relapsed, measured at the same time point. An example: treatment A response rate, 12.5%, 0.125. Treatment B response rate, 10%, 0.10. Difference, 0.025. NNT equals 1 divided by 0.025 is equal to 40. Interpretation rules. NNT value. Meaning: clinical actionability. 2. Very large effect. You'd see a difference after treating just 2 patients. 5 to 10. Moderate to large effect. Clinically meaningful, detectable in daily practice. Less than 10. Rule of thumb for clinically meaningful. Routinely encountered in practice. 40. Small effect. Hard to detect clinically. Other factors: cost, side effects, patient preference, likely more important. 100 plus. Trivial effect. Unlikely to matter in routine care. Rounding convention. Always round up to the next whole number, e.g., NNT of 2.1 or 2.7 both become 3. This avoids exaggerating treatment differences. A little bit extra. Number needed to harm, NNH, the evil twin. Same calculation, but for adverse outcomes. Weight gain greater than 7%. Akathisia, sedation, discontinuation due to side effects. Interpretation: higher NNH equals smaller harm difference, better safety profile. Lower NNH equals more concerning harm difference. The likelihood of being helped versus harmed. LHH combining NNT and NNH. LHH equals NNH/NNT. LHH, 1 equals more likely to be helped than harmed. LHH equals 5 equals treatment is 5 times more likely to produce benefit than that specific harm. Caution: the benefit and harm being compared must be of similar clinical importance to the patient. Comparing remission, major benefit, to transient nausea, minor harm, is problematic. Key cautions and limitations. 1. Binary outcomes only. NNT cannot be calculated from continuous measures, e.g., 5-point improvement on a rating scale, or 3 kilograms weight gain. Those require different effect size statistics. 2. Time dependent. NNT changes over time. A treatment might have NNT equals 10 at week 4, but NNT equals 6 at week 12. 3. Depends on definition of response. If response means 20% symptom reduction, trivial, versus 50% reduction, meaningful, the NNT will differ dramatically. Always check the definition. 4. Generalizability. NNT from a clinical trial applies only to patients similar to those in the trial. Your patient may be different, older, sicker, more comorbidities. 5. Trial quality. NNT is only as good as the data behind it. Flawed trial equals useless NNT. 6. Non-significant results. When the difference between rates is not statistically significant, the 95% confidence interval for NNT includes infinity and spans from a negative to a positive number. Very difficult to interpret. 7. Harm severity varies. Comparing NNH for transient nausea versus tardive dyskinesia or agranulocytosis is inappropriate despite both being harms. Consequences matter.